How's it going, guys, and welcome back to Next Gen Vision. Today we're going to look at creating a blockchain-based ticketing system. Now, before we get into the code, I'm excited to say that Next Gen Vision has partnered with Korea Blockchain Week, and they're giving our community a special offer. So just look in the description for details on that. If you are looking at getting into the blockchain space, I would highly recommend you go for this event. They've got over 570 speakers, and it really is a great opportunity to interact with other people in the crypto space. All right, let's get into the coding. All right, so this is the Remix homepage. So Remix is this really cool online IDE that actually connects directly to an Ethereum node, right? So you can directly deploy your smart contract from here onto the blockchain. Now we've got the file explorer on the left, then we've got the Solidity compiler. Now the compiler is responsible for changing the human readable code into bytecode, right? So that computers can read. So we've got a whole bunch of different versions here. The latest one is 0.8.26. Then we've got the deploy and run transactions. So over here we'll have the environment. So you can choose whether you want to upload your smart contract onto a virtual machine. So this will be just for testing purposes. Or you can actually connect your MetaMask wallet and then can upload your smart contract onto the Ethereum mainnet or any layer 2. All right. Then you can choose the account with which you want to interact with. These on the virtual machine are just dummy accounts with 100 ETH in each, so they're obviously not real. Then gas limits. So gas is the transaction fees. So over here you can put whatever your transaction fee limits are. And then we've got a value section. Now, when you want to pay to a smart contract, you need to put in the value here that you want to pay to the smart contract, and then that'll transfer the funds into the address of the smart contract. All right, we will be interacting with this during this tutorial. And then we'll have our deployed contracts here. So the deployed contracts is for you to interact with the functions once you've deployed the smart contract. All right, we're going to go into our file explorer. We're on the default workspace. We'll just add a new file and we'll call it KBW2024. All right. Oh, yeah, you have to end it with .sol. I forgot that, but it did it for me. .sol just lets the computer know that it is a Solidity file. All right. So we're going to start off by defining the license under which we're deploying the smart contract. So you have to do this for all smart contracts. So you're going to say SPDX and then license identifier, and then that'll be MIT. So MIT is an open source, meaning anyone can use it. Then next we'll do the Solidity version that we'll be using. So it'll be Pragma Solidity, and then it'll be, let's go a little closer here, 0.8.26. All right, so the latest version. Okay, perfect. Now let's define our contract, right? So we're going to say contract, and then we're going to call it KBW2024. All right. Now what we have to do is actually define the state variables that we're going to use throughout the smart contract. So we're going to have, the first one is a uint 256. So uint defines the variable as an unsigned integer, right? So any positive whole number. So it's going to be a public function so anyone can see it, and it's going to be called total tickets, right? So this will be the total number of tickets that there are for the event. We'll assign values to this later. All right. The next one that we have to do is the ticket price, right? So that'll also be a uint 256. It'll also be public, and that'll be called ticket price. All right. Then the next one is the number of tickets that we've sold, right? So we have to keep track of how many have been sold so we know how many are still available to be sold. So it'll be uint 256. Public, and then tickets sold. All right. The next thing that we have to do is actually keep track of which account has got how many tickets, right? So if I bought 10 tickets, then my account needs to reflect 10 tickets. So we're going to do this with a mapping. That's similar to a dictionary in Python in which you've got key value pairs, right? So we're going to say mapping, and then it'll be an address which points to a uint 256. All right, so an address points to a number of tickets. And then this will also be a public, and we will call it tickets held. All right, cool. Lastly, what we're going to do is keep track of who the owner of the smart contract is, right? So at the end of the day, when people buy tickets, they're going to be sending the funds to the address of the smart contract, but then we need to allow the owner to actually take the funds from the smart contract address into his personal account. All right, so we'll say address, and then also public, and that'll be the owner. Okay, perfect. We have defined all the state variables needed for this project. Next, what we're going to do is write the constructor function. Now, the constructor function is a function that's run once and only once upon deployment of the smart contract. So we're going to say constructor. And now what we need from the constructor is for the owner to tell us how many tickets there'll be in total and what the ticket price is, right? So it'll be uint 256 and then underscore total tickets, and then uint 256 and underscore ticket price. Okay, perfect. Now what we're going to do is assign the total tickets to the total ticket state variable and then the ticket price to the ticket price, right? So we're going to say total tickets is equal to the underscore total tickets. All right. And then the next one is assigning the ticket price. So we're going to say ticket price is equal to the underscore ticket price. Perfect. Lastly, what we're going to do is define who the owner of the smart contract is, right? So the owner of the smart contract will be the person deploying the smart contract. So we're going to say owner is equal to the message.sender. Okay, perfect. So message.sender takes the address of the person calling the or deploying the contract and assigns it to owner. All right. All right, so the next thing we need to do is actually allow someone to purchase a ticket, right? So we're going to say function and call it purchase ticket. And then the information we need from them is how many tickets they want to purchase, right? Or let's say purchase tickets with an S. All right, so we'll take in a uint 256, and then that'll be the underscore tickets, right? And now this function is going to be public, so anyone can call it, but it's also going to be payable. Now, payable means that when someone calls this function, they can also send funds from their account to the smart contract account. So we'll say public and payable. All right, perfect. So now what we need to do is a few checks before we allow someone to purchase the tickets. Firstly, what we need to do is make sure that there are enough tickets available, right? So if the total tickets was 100 tickets and we already sold 95, so tickets sold is 95, and they're wanting to buy 10 tickets, then there aren't enough tickets, right? So we can't proceed with that transaction. So we're going to say require, and then the underscore tickets plus the tickets sold must be greater than, less than or equal to the total tickets, right? And then if it isn't, we're going to leave a message and say, soz, there are not enough tickets available. Okay. Okay, the next require statement is going to be to check that they sent in the correct amount of funds. So if one ticket costs 1 ETH and they try to buy 1 ticket, but they only send through half an ETH, then they can't buy the ticket, right? So we're going to say require, and then the message.value. So message.value takes the amount of Ether that they sent and assigns it to message.value, right? And this should be equal to the underscore tickets, right? So the number of tickets times the ticket price. And then if they send through the incorrect amount, we'll leave a message saying not the correct payment amount. All right. Okay. So if these two things happen successfully, meaning that there are enough tickets and they pay the correct value, then we're going to let them have the tickets, right? So we're going to assign the tickets to their address, right? So we're going to say tickets held, and then of message.sender must plus equal the underscore tickets. So plus equals here says whatever the current value of the tickets is that they have, just add the tickets to that, right? So if they already had 10 tickets and they bought another 10, then make it 20. All right, next what we need to do is add the number of tickets to the tickets sold, right? So if 50 tickets were already sold and we sold another 10, then 60 are sold. So tickets sold is plus equal to the underscore, right, underscore tickets. Okay, perfect. Why don't we go ahead and deploy the smart contract that we have so far just to make sure everything is working as expected. So we're going to go to a compiler. We're going to compile the smart contract, and we've got the green tick, so everything's all right. Then we're going to go to deploy. We're going to use the virtual machine. We'll use the first account. And then for deployment, we need to give the total number of tickets and the ticket price, right? So the total tickets will be 100. And let's say the ticket price is 100 Wei. Now, for those of you who don't know, you get all of these divisibilities of ether, right? So 1 ether is 10 to the 18 Wei, right? So 1 with 18 zeros. So that's because in crypto you can't really have decimal places like point something. So they divide it by just making the decimal places way long. All right, so let's make our ticket cost 1 million Wei. So it'll be 1 with 6 zeros. Okay, let's transact. Let's bring this up a little. Okay, so transaction went through successfully. Now let's try and purchase a ticket. So we're going to change the account to the second one. And then down here we've got our deployed smart contracts. So let's see. So we can click on the owner to retrieve the address of the owner, which is that OX5B. And then if we go up here, we can see OX5B is in fact the owner of this smart contract. Now the ticket price is 1 with 6 zeros. So let's try buy some tickets. So we're going to say purchase tickets. You'll see it's red. This just indicates that it is a payable function. So we want to buy 2 tickets. And then up here on the value, we need to write the value. Let's make it 2. So this will be 2 with 6 zeros, right? Okay, cool. So if we transact, that should go through. All right, successful. So now the funds went from our account into the smart contract account. So if we see tickets sold, there'll be 2 tickets sold. Okay, perfect. So this works as we expect. Let's make some space here. All right. The next thing we have to do is actually write a function for people to use their tickets, right? So we're going to say function and then use ticket or tickets. And then we need to know how many tickets they want to use, right? So uint 256 and underscore tickets. All right, this is going to be a public function. Cool. Now, what needs to happen when someone wants to use a ticket? Well, there's just one thing we have to check, that they have enough tickets in their account for the number of tickets that they want to use. So we'll say require, and then the tickets held of the message.sender must be greater than or equal to the underscore tickets, right? And if they don't have enough tickets, we're going to leave a message saying, bro, you don't have enough tickets. Okay. So if they do have enough tickets, then what we need to do is reduce the amount of tickets in their account by the number of tickets that they're using, right? So we're going to say tickets held of message.sender, and then this must minus equal to the underscore tickets. All right, and that is all we need to do for this function. Now, the last function that we have to write is actually for the owner to withdraw the funds, right? So whenever someone is buying a ticket, they're sending funds to the smart contract address. But now we need the owner to actually be able to withdraw those funds. So we're going to write function and then withdraw. And then there's no input here, and it'll be a public function. All right, so we've got one very important require statement here. We have to make sure that the person calling this function is in fact the owner of the smart contract, right? Like not anyone can just call withdraw and send the funds to their personal accounts. So we're going to say require, and then the message.sender must be equal to the owner. And if it isn't, then we're going to leave a message saying, unfortunately, you are not the owner. All right, cool. Now, if the person calling the function is in fact the owner, then we want to be able to send him the funds. So we first have to see how much money there is, right? So we're going to say uint 256, and then we're going to say balance. And then that'll equal to the address this, right? So address of this smart contract, and then dot balance, right? So this will assign the balance of ether of the smart contract to the balance variable. All right. All right, now what we're going to do is transfer that balance to the owner's account. So we're going to say payable, that's a keyword, and then the owner, so that'll be the owner's address. So we want to pay the owner's address, and then dot transfer, and then the balance, right? So all looks good, no errors. Let's go ahead and compile and see if everything goes through. All right, green tick, so it compiled successfully. Then we can go to deploy. So we're going to deploy the smart contract down here. So let's go back to the first account. Okay, so we're gonna issue a total number of tickets of 100, and the ticket price will be 1 ether, right? So that's gonna be 1 with 18 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. All right, so 1 ether. So let's transact. All right, that went through successfully. Now we can go down here to our smart contract. So we can see the total tickets sold is 0. The ticket price is 1 ether, and then the owner is that address. And the total tickets is 100. So let's go ahead and try purchase a ticket, right? So we're going to go to the second account, and we're going to go to purchase ticket, and then the number of tickets is, let's say, 2. Well, let's make it 10 for funsies. And then under the value that we're going to send to the smart contract, it'll be 10 ether, right? And then let's transact. Cool, it went through successfully. Now, let's try buy more tickets, but let's send the incorrect amount and see if it goes through. So we'll still buy 10 tickets, but we'll make the amount that we're sending, let's say 5 ether. Oh wait, that's incorrect. Up here, so 5 ether. Let's transact, and then you'll see we get the error message, and then the reasoning is down here saying not the correct payment amount. Okay, so while we're on the second account, why don't we go ahead and try withdraw the funds, right? So we'll go withdraw, and then another error message saying, unfortunately, you are not the owner. So if we go to the top and now change the account to the first account, so that's the owner's account, you'll see he's got 99 ether currently. Let's go ahead and withdraw the funds. So we'll click withdraw. It went through successfully, and his balance is now 109 ether. So he got the funds. All right, guys, I hope you guys found that video helpful. Just another reminder that we are media partners for Korea Blockchain Week, and we've got some special offers for our community. So just look in the description to get involved there.